NASA says its Pioneer 1 test, the most distant human-made object known to man, is sending usable information to Earth again. In the universe, we have no clue about what it is aside from the fact that we can check it. Pilgrim 1, the famous space test shipped off by NASA more than 4.5 decades ago, has recently sent back a message that has sent shockwaves through the academic community. After traveling nearly 14 billion miles from Earth, Voyager 1 has made a discovery so significant that it has redirected its mission toward our planet. But what exactly could this discovery be? Could it be evidence of extraterrestrial life, a priceless anomaly, or something even more extraordinary? In this gripping analysis, we will unveil these astonishing revelations as Voyager 1 has recently made a startling discovery that caused it to unexpectedly pivot toward Earth. Pioneer Twin Test. If certain extraordinary events hadn't coincided, the Voyager twin tests might never have left Earth. In this case, the aligning stars were the 4 largest planets in our solar system. Over 200 years ago, during Thomas Jefferson's presidency in the 19th century, these planets aligned in a rare planetary arrangement. At first, this fascinating alignment went largely unnoticed. The first person to recognize its importance was Gary Flandreau, a graduate student in aeronautics at the California Institute of Technology in 1965. At the time, space exploration was just beginning. Working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, Flandreau was tasked with figuring out the best way to send a space probe to Jupiter, or even further to Saturn, Uranus, or Neptune. Using only a pencil, he meticulously plotted the orbital paths of these giant planets and made an incredible discovery. In the late 1970s and early 1980s, all 4 planets would align in such a way that they could be visited in a single mission. This arrangement meant a spacecraft could use the gravitational pull of each planet to slingshot itself to the next, significantly reducing travel time. Flandreau determined that this arrangement could shorten the flight time from Earth to Neptune from 30 years to just 12 years. However, there was a catch. This planetary alignment only occurs once every 176 years. To take advantage of this unique opportunity, a spacecraft would need to be launched by the early 1970s. The Voyager missions begin. NASA seized this rare chance and built 2 spacecraft for the journey, Voyager 1 and Voyager 2. These spacecraft were launched on an incredible mission to explore the outer planets of our solar system, thanks to Flandreau's visionary calculations. Voyager 1 was launched on September 5, 1977, at Cape Canaveral, Florida, propelled by a powerful Titan IIE rocket. Just 16 days earlier, on August 20, 1977, Voyager 2 had already begun its cosmic journey. The primary mission of the Voyager spacecraft was to investigate the massive gas giants of our solar system, such as Jupiter and Saturn, along with their moons. However, these fearless explorers exceeded all expectations. They ventured far beyond, pushing the boundaries of exploration and traveling farther and longer than any other spacecraft in history. Beyond the solar system, Voyager 1 and Voyager 2 have ventured into a region known as interstellar space, an entirely unfamiliar area beyond our solar system. These spacecraft, now more than 12 billion miles away, continue to astonish researchers with their remarkable discoveries. Most recently, they made a discovery so shocking that it has captivated everyone. The Voyager missions have accomplished some truly extraordinary feats. Decades ago, they explored the moons of Jupiter and Saturn, surprising scientists who initially believed them to be dull and heavily cratered like our moon. These moons turned out to be dynamic worlds. In 1986, Voyager 2 made history by becoming the first spacecraft to fly past Uranus. Just 3 years later, it flew past Neptune, achieving a milestone unmatched by any other spacecraft. To keep the Voyagers operational, NASA implemented clever strategies, deactivating non-essential components like extra instruments and heaters to conserve power. This approach aims to keep the spacecraft functioning until at least 2030. A stunning new discovery. For the dedicated scientists and engineers who have been part of this remarkable journey since its inception, this mission evokes bittersweet emotions. Their hard work has paid off, and just when they thought the Voyager missions were nearing their end, an astonishing new discovery emerged from the depths of space. Voyager 1's transmission brought groundbreaking data and revelations that stunned experts. For example, during their initial missions, the Voyagers captured the first close-up views of Jupiter's and Saturn's moons. These moons, once thought to be lifeless and heavily scarred like Earth's moon, turned out to be active worlds. Voyager 1 reached Jupiter in March 1979, just 18 months after its launch. Voyager 2, following a slightly different path, arrived in July of the same year. Both spacecraft were equipped with cameras designed to capture sharp, high-resolution color images. They took over 33,000 photos of Jupiter and its moons, revealing captivating details. For instance, Europa, one of Jupiter's 53 named moons, was discovered to have a cracked icy shell estimated to be over 60 miles thick. As the spacecraft departed the Jupiter system, they received a gravitational slingshot boost, propelling them toward interstellar space. At Saturn, Voyager 1 passed through the planet's majestic rings and flew by Titan, a moon shrouded in orange haze, before traveling northward out of the plane of the planets. Voyager 2, continuing its solo journey, visited Uranus and Neptune in the following years, making new discoveries and breaking records along the way. Uranus, the space transport challenger, unfortunately detonated soon after takeoff, killing all 7 crew members, including Krista McAuliffe, a secondary school teacher from New Hampshire who was set to become the first civilian to travel into space. 3 years later, as Pioneer 2 zoomed around 2,800 miles above Neptune's striking pale blue methane sky, it encountered the fastest winds recorded on any planet in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, was revealed to be one of the coldest places in our vast neighborhood, with surface temperatures dropping to a stunning -235 degrees Celsius. The moon's icy volcanoes were another fascinating discovery, launching nitrogen gas and fine particles up to 5 miles into its atmosphere. After Pioneer 2 captured mesmerizing images of Neptune and its moons, both spacecraft were scheduled to shut down their cameras, marking the end of their official mission. However, astronomer Carl Sagan, a member of the mission's imaging team, intervened. Despite the mission's planned conclusion, NASA extended it, hoping the spacecraft would venture into interstellar space. Renamed the Voyager Interstellar Mission, the probes were set to continue their journey into the unknown. Sagan persuaded NASA to allow Voyager 1 to take one final series of images. On Valentine's Day in 1990, the spacecraft turned its camera back toward the inner solar system and snapped 60 final photos. Among these was the iconic pale blue dot image of Earth, taken from a staggering distance of 3.8 billion miles. In the image, Earth appears as a tiny speck, barely visible against the vastness of space, illuminated by a faint ray of sunlight bouncing off the camera's optics. We have learned so much about the planets and moons in our solar system, each uniquely fascinating, even those farthest from us. Voyager's journey beyond the heliosphere in August 2012 marked a historic achievement. By crossing the heliosphere, a vast region of charged particles released by the Sun, Voyager 1 became the first human-made object to enter interstellar space. This extraordinary milestone was confirmed the following year when a study was published in the journal Science. During a solar outburst between April 9 and May 22, 2013, Voyager 1's plasma wave instrument detected electron vibrations, signaling a region of higher particle density outside the heliosphere. Scientists pinpointed the official exit date as August 25, 2012. This conclusion was based on measurements of charged solar particles and cosmic rays. Coincidentally, this groundbreaking event occurred on the same day that the legendary Apollo 11 astronaut Neil Armstrong passed away. On this significant date, Voyager 1 observed a 1,000-fold drop in solar particles and a 9% increase in cosmic rays originating from outside the solar system. These findings illuminated the dynamic and ever-changing nature of our cosmic neighborhood, showcasing the complexity of space exploration. As of now, Voyager 1 has reached an incredible distance of 11.25 billion miles from the Sun, approximately 121 astronomical units. NASA's Planetary Science Division continues to study the solar system using various techniques, including flybys, orbiting, landing, and sample returns. The Voyager missions laid the foundation for this approach, serving as pioneers in planetary exploration. The concept of gravity assist, a technique using the gravitational pull of a planet or celestial body to adjust a spacecraft's speed and trajectory, was critical to Voyager's success. This method not only enhanced planetary science but also revealed the vastness of space. The Voyager spacecraft relied on the Deep Space Network, DSN, an essential communication system resembling a giant global web of radio antennas, to send and receive data. The DSN, with massive antennas up to 70 meters wide, captures the faint transmissions from Voyager. It amplifies these signals into usable data for scientists and also sends instructions back to the spacecraft, enabling two-way communication between Earth and the most distant human-made objects in space. Currently, Voyager 1's onboard flight data system, which gathers information from scientific instruments, is facing challenges. On November 14, engineers detected that the system was stuck in a loop, repeatedly transmitting the same pattern of ones and zeros. While Voyager 1 can still execute commands, no new scientific or engineering data is being sent back to Earth. NASA is working to identify the root cause of this issue, which could take weeks to resolve. Interestingly, Voyager 1 experienced a similar problem in 1981. However, the current issue seems unrelated to past malfunctions. Engineers are cautiously examining all possibilities and referring to decades-old manuals for guidance, as they carefully consider each step to avoid further disruptions. Despite these challenges, the Voyager missions have far exceeded expectations, becoming the longest-running space missions in history. Even with diminishing power, the spacecraft continue to provide valuable insights into the universe. As they journey through interstellar space, scientists remain eager to study changes in particles and magnetic fields, demonstrating the enduring significance of these groundbreaking missions.